Welcome to another lesson. Today we will be looking at a feedback device known as encoder. So what is an encoder? An encoder is an electronic device that is used to provide feedback to programmable logic controller or PLC. In another word, it is used to sense position, speed, count, and many more special functions. Encoders convert motion to an electrical signal. These converted signal will be feedback to a controlling device, such as a PLC. The converted electronic signal will be scaled. The scale value will be used within the PLC program. There are different types of encoders, which are rotary encoders and linear encoders. While based on technology, encoders are of different types. This includes but is not limited to mechanical, magnetic, electromagnetic and optical encoders. So what exactly are optical encoders? Optical encoder is the most widely used encoder motion translating technology. This type is further divided into two, which are absolute and incremental encoders. What is an incremental encoder? An incremental encoder is a linear or rotary electromechanical device that has two output signals, high and low. It transmits pulses when the device is moved. As the device is moved, it will intercept the beam of light that is transmitted between the transmitter and the receiver. When the beam path is not interrupted, the signal will be high or 1. And subsequently, when the beam is interrupted, the signal will be low or 0. These signals will be transmitted to the PLC in form of 1 and 0. What is an absolute encoder? An absolute encoder is an encoder that provides a unique position value or data at every point of rotation, this representing the absolute position of the encoder. From the moment you switch it on, an absolute encoder can tell you the exact position of the rotating shaft that it is measuring. It does this by using an optical, magnetic, or capacitive sensor to read a unique code off of a disk that rotates with the shaft. Crucially, absolute encoders can do this without needing to turn the shaft and can keep track of this position even in instances of temporary power loss. The more unique codes there are on the encoder's disk, the more precise your position reading will be. What is the major difference between incremental and absolute encoders? Although both the incremental and absolute encoder are similar in applications, incremental encoders are usually referenced to a known fixed location or home. This is done in order to achieve a meaningful positioning information. This is because incremental encoder loses its position when power supply are interrupted, while an absolute encoder maintains the position of the shaft. As mentioned earlier, the position of absolute encoders are known as soon as you deliver power to it. You do not need to wait for homing or calibration sequence to be completed before you can get the position data you need. This will make the system to start more quickly during power failure, which means even if the shaft has been turned while the encoder was off, the new shaft displacement will be transmitted back to the PLC. Equally important, an absolute encoder will provide a true position in real time, because these days, more systems are becoming digital with connections to a central communication bus, and being able to poll the encoder for real-time position when needed, with minimal latency, is of great benefit. This enables to keep track of your position in real time, however with an incremental encoder. Even when homing sequence are carried out during startup, you will need to keep track of all the pulses with external circuitry, typically via quadrature decoding. This extra circuitry connection results to some latency in determining the position of the encoder in real time. In all, the differential features mentioned earlier come with some extra cache. Absolute encoders are known to be a little bit more expensive than the incremental encoder. This is due to the extra circuit it entails. But generally speaking, the value of money is gotten back during its applications.